I'm the technically challenged Susan Orgill. I'm a soil researcher based at the Wagga Wagga Ag Institute, and my area of research is soil organic carbon. So thanks very much for the invitation to come and speak today. The scenario I've been presented, I'm sure has been circulated to everyone, but what I've gone through and I've just highlighted, I guess, the key points that I'll be touching on around the benefits of improving soil organic carbon, the opportunity to trade soil carbon and get soil carbon credits, around the trickiness and whether or not there's, I guess, anything spooky about increasing soil carbon, because that's often what I get asked about as well. The importance of knowing soil carbon fractions, but whether or not that's something that producers should be monitoring. And of course, the best ways to improve soil organic carbon under perennial pastures. And I'll also speak a little bit about pasture phases, because I know that there's a few people with mixed farming properties as well. So to begin with, I guess, the brief from Lisa said that everyone's got various I guess, backgrounds and exposure to soil carbon. So I kind of wanted to build on a bit of a foundation of knowledge together throughout this presentation. So if you're someone who's just struggling because you've been on the screen now for like 2.5 hours, this next 2 slides is all you need to remember from my talk, because this is where all the secrets are. So I want to talk about the flows of soil organic carbon around the landscape and how carbon actually accumulates in soil. So to begin with, we have lots of carbon dioxide in our atmosphere, and plants, through the process of photosynthesis, take carbon dioxide from the atmosphere. They use water and energy from the sunlight to photosynthesize and grow. Now, this turns carbon from a gas in the atmosphere into glucose or energy within the plant, which the plant can then use to grow leaves and stems above ground, or it might go below ground in the form of roots and root exudates. So approximately 60% of the total carbon that's sequestered through this process actually goes below ground. Of that 60% that goes below ground, approximately half of that leaves the plant roots in the form of root exudates. So root exudates are carbohydrate-rich signals that the plant roots will leak out into the soil to attract soil microorganisms to come and live within the rhizosphere. So the rhizosphere is that very thin layer of soil around the plant roots. It's about 5 millimeters in diameter, and it's what, when people pull out plants and you can see those root dreadlocks, that's all the root exudates, that really hive of activity for soil organisms around plant roots. And it's a really good indicator of a healthy soil. And I think, right, why would the plants exchange so much carbon that they use through this photosynthesis process to attract soil organisms to live within the root zone? And it's a really important question. It's an even more important function that those root exudates and that partnership between plants and soil microbes actually have. So that the plants know through this carbon exchange, they can have organisms live within that rhizosphere, which can help them acquire nutrients, can help them explore a greater volume of soil for nutrients and water, and also moderate things like soil pH within that zone. So the plants can switch these root exudates, these carbohydrate or carbon-rich signals, depending on what they need. So if they need to acquire phosphorus or zinc, if perhaps soil acidity is a challenge, they can actually switch the type of messages that they put into the soil to moderate what type of organism is in the soil. So these root exudates, they may only last within kind of days to weeks, actually probably even less than that within the soil, but they're a really important, I guess, function of accumulating carbon within soil. Now we have these above ground and below ground pools of soil organic matter. Once it's within the soil, that's what we're dealing with when we're looking at a soil test. So above ground, it could be leaves, litter, and also manure from our grazing livestock. Below ground, we've got roots, root exudates, and also that microbial life within the soil. Now, once organic matter is in the soil, there's different pathways that it can take. So it can be protected nice and tightly within a soil aggregate or a crumb of soil. And when I say protected, what that means is it's just protected from further decomposition. So it's kind of a longer term store within the soil. Soil organic matter can be decomposed by microbes, and that's the way that we build humus within our soil, and that's related to a huge amount of functions that we'll talk about throughout this presentation. The type of organic matter can be changed through that decomposition process so that it means it's more able to be associated with clay minerals within the soil, and then it becomes chemically protected. So you have these organo-mineral associations. So different types of organic carbon compounds which can be attracted to clays within the soil and then stored. So there's these different pathways that organic matter can take. There's also different fractions of carbon depending on which pathway it takes throughout the soil. So we've got our particulate or our labile organic matter. That's what's most tastiest to our microbes. It's that energy-rich kind of driving of those microbial processes as part of that organic matter pool. There's charcoal, so more inert forms of carbon that are really important for microbial habitat within the soil and can perform other functions like cation exchange capacity. But really, that's not something that's easily managed. Although we know that within our soil, in Australian soils, in some cases, up to 35% of that total organic carbon pool, so that total pie, might be taken up by charcoal, so very fine bits of char within the soil. Often it's much less than that though. And then we've got our humus. So our humic pool, which is basically microbial products and microbial detritus. So that's kind of that form of really stable organic carbon within the soil. Very important for the functions of nutrient cycling and water holding capacity as well. And that's what gives the soil that beautiful dark color and rich texture that you get in high organic matter soils. We also, as I said, this is a flow of carbon through the soil. So we also have carbon dioxide leaving the soil in the form of plant and soil respiration. So microbes, just like us, as they decompose organic matter, they respire carbon dioxide. And we can have carbon leaving these sites through the process of soil erosion. So the physical removal of soil and carbon that's associated with that, or fine fraction organic matter, leaving the site in times when we perhaps have low ground cover and being moved off-site. So an extreme case of this might be organic matter which ends up in New Zealand. Otherwise, it might just be more locally redistributed throughout the landscape. And the important thing to remember about that is it might go somewhere in the landscape where it's more prone to decomposition. So therefore, it might return to the atmosphere. So if I was me, and I frequently am, I'd be thinking there's three main things that we can influence here if we want to build soil organic carbon. We can make sure that we've got as many solar panels within our paddocks as possible photosynthesizing. So with our grazing management, what can we influence so that we've got longer periods of actively growing plants? We can make sure that our plants have all the nutrients they require so they grow big and healthy so that they're pumping carbon into the soil. Once that carbon is in the soil, we can influence those processes of stabilization. So we can have practices which we know support and enhance structural stability, so the way that the organic matter gets wrapped up and stored within the soil. We also know that we can influence through soil nutrition that microbial process and the formation of humus in the soil. The other thing that we can influence is that loss pathway of carbon. So we can make sure that our grazing management practices or our stubble retention is something that fosters maximum ground cover or optimum ground cover for your system as well. So we're keeping carbon in the soil. Now that flow of carbon that we can see around this landscape is the same in this dual purpose crop here out at Beckham. It's the same here in this tablelands pasture at Brewer. And that flow of carbon is the same here in this Mitchell grass paddock out near Cobar. What's different is the size of the arrows. So the flow remains the same. So for you, it's about thinking about what can I do to grow more biomass, to enhance and protect soil structure and build humus and retain ground cover. And they're all things that are synergistic with good land management and enhancing productivity as well. So I've used a couple of terms interchangeably here. I've spoken about soil organic matter and soil organic carbon. So I just want to point out the difference between the two. So soil organic matter, for a soil scientist, and when we take the soil back to the lab, it's everything that's less than 2 millimeters in diameter. And that includes partially decomposed organic residues, microbes, so that living microbial biomass that's within the soil, so that microscopic livestock which is eating the particulates, humus and charcoal. Now the reason we have it as that less than 2 millimeter fraction is that first of all, it can be standardized across all laboratories. And second of all, it's the less than 2 millimeter fraction of organic matter that's associated with a lot of the big soil functions that or soil properties that we talk about within soil organic carbon's realm of influence. So that's why we have that. But in practice, we know that we've got organic matter, so roots and mycorrhizal fungi, which is extending networks throughout the soil, which are far bigger than that 2 millimeter cutoff. So in practice, we know that we're actually influencing organic matter stocks in soil that we're not always capturing when we have our lab-based measurements. But there's some very good reasons that we need to standardize that. Now, that's organic matter. Carbon, on the other hand, is what we actually measure. And we know that soil organic matter is approximately 58% carbon, 42% other stuff. And it's the other stuff which is really important for our productivity as well. So things like nitrogen, phosphorus, and sulfur, for example. So when we get our soil test back, I guess the first thing to remember is really we should be looking at the carbon concentration, not necessarily the soil organic matter content, which is sometimes reported, because the soil organic matter content is a calculation, whereas the carbon content is the actual measurement. Now, while we're on definitions, we've got our soil organic carbon concentration. So that's the total amount of soil organic carbon within that sample that you submit to the lab. Now, this might be reported as a percentage or as a grams of carbon per 100 grams of soil. So they're interchangeable, those two units. And that includes that total organic carbon pool. So your particulate or your labile carbon, the charcoal fraction, and the humus as well. In soil land, where I live, we also talk about soil carbon stocks. So that's the tons of carbon per hectare. And generally, this is measured to 30 centimetres because that's the international protocols for measuring soil organic carbon stocks and reporting. Now, what soil organic carbon stocks are, it's the tons of carbon per hectare. And the way we calculate this is we use the soil organic carbon percentage or the concentration. We multiply that by the depth over which that sample was collected, and then we multiply that by the bulk density of the soil. Now, the bulk density of the soil is the mass of soil for a given volume, because we've got a concentration of carbon, which comes back from the lab. We know what the depth is, so therefore we need to know what the density of the soil is if we want to talk about it in the units of tons of carbon per hectare. Now, for carbon accounting, they'll also account for gravel concentration. But for this example, this is like a really simple way that you could calculate soil organic carbon stocks on your farm. And if you don't have the bulk density information, you can certainly just look up some regional estimates of that or speak to your local soils group about that. Now, the other unit that we talk about in terms of carbon trading is carbon dioxide equivalents. And we know that 1 tonne of soil carbon is equivalent to 3.66 tonnes of carbon dioxide. So if we know that the carbon price, I think at the moment on the voluntary market was about $25 a tonne, and that's carbon dioxide equivalents. Okay, so 1 tonne of carbon in soil is equivalent to 3.6 tonnes of carbon dioxide in the atmosphere. All right, so if we run through an example of using that calculation, and you'll get access, I'm assuming, to all of these slides as well. You've got, if we had 2.7% soil organic carbon in the top 10 centimetres of the sample that we submit to the lab, and we've got a bulk density of 1.03, that calculation becomes 2.7 times 10, which is the depth, times 1.03, and that's 27.81 tonnes of carbon per hectare in the top 10 centimetres of soil. Now, if we wanted to know what the sequestration rate was, we'd take our baseline sample, we'd take our sample, say 5 or 10 years later, and we'd see what the difference was. And the sequestration rate, which is the tonnes of carbon per hectare change per year, would divide by the amount of years between those 2 points in time. And that gives us an estimate of that carbon sequestration rate. But it's not necessarily linear. In fact, we know that it's not. So most of the change in soil organic carbon occurs within the first 5 to 10 years of changed management. And it kind of occurs like in a curve. So it kind of is really rapidly changes, and then it will continue to increase, but at a decreasing rate. So the curve kind of flattens off. So back to the scenario now. There was some questions around how long it takes, carbon fractions, what should we be doing, and how do we actually look at carbon levels within soil. So I'm a big advocate of soil carbon monitoring, obviously. In terms of what we request from the lab, it's soil organic carbon, the total amount, and we recommend the dry combustion test. So that might be referred to as a LECO or a JUMIS test. And the reason that we do that is that, first of all, it accounts for that total organic carbon pool, and we know that it's a nice standard test. Now, if your soils have carbonates in them, so indicated by little bits of free limestone or a high pH, which, given that we've just had Jason talking about soil acidity, that might limit kind of the audience for that particular test. The lab just needs to make an extra step, so they need to know that, and they just do a sulfurous acid pre-treatment before doing that dry combustion test. But rule of thumb, that's the test that we generally recommend across Australia for looking at total soil organic carbon. For monitoring, looking at 0 to 10 centimetres is completely adequate, but if you're going to be adopting some of the recommendations from Jason, for example, in looking at soil acidity in those 5 centimetre increments, by all means, adding soil organic carbon testing onto that regular testing would be hugely beneficial. It's the top 5 centimetres, which is most management sensitive, so you might even detect a change more readily if you're doing those finer increments. But building it into your normal agronomic practice of 0 to 10, it's a really cheap test just to add on to those tests at most commercial labs. For soil organic carbon trading, though, that's that 0 to 30 centimetres. And then if you're really keen, you can go 30 centimetres plus. That's an option. So monitor frequently. As I said, just throw that test on your request list for your other analysis that you're already getting. Set your own benchmarks, GPS the location. I think Jason touched on this as well. So monitor your own trends and think about and try and unpack what's influencing soil organic carbon levels. It will bounce around a bit with season, but we certainly know that with some land management practices, despite the drought, we still get this increase in soil organic carbon. And if I get time at the end, I can show you an example of that. For getting ACCUs, so that's Australian Carbon Credit Units. So that's the unit that you get to trade soil organic carbon. That's a different game. And there's like paperwork, planning, mapping, specialized sampling gear, and there is a process, right? So I'd recommend that you'd work with project managers and explore ideas around that. Certainly, carbon trading's real and there's a market for it, and that market is not only emerging, but that's strengthening. So I think it's certainly an exciting space, but because you are selling a product, it's just a different game. So why are we interested in soil organic carbon? Certainly there's benefits way beyond trading. So those production benefits around nutrient cycling, water infiltration and storage, plant growth and quality all mean that increasing soil organic carbon is a very safe bet for your farm business goals. It's really important. And if we think about what some of those increases or benefits might be, we know that with an increase in soil organic carbon, you can increase your cation exchange capacity. So Jason may have mentioned this, I missed the first part of his talk, but cation exchange capacity is your soil's ability to hold on to and exchange nutrients or cations. So your cations are your calcium, magnesium, potassium, sodium, and aluminium. So your positively charged ions. It's an inherent indicator of fertility as well, and it's driven by two things. It's largely driven by the amount of clay and the type of clay in your soil, and also soil organic carbon. So we know on a sandy soil, your amount of soil organic carbon can be responsible for up to 90% of that cation exchange capacity. In clay soils, it might be 25%, might be determined by the amount of soil organic carbon, but that's still a real number and that's still important. So the way we like to think about that is let's say we're all sitting in a room together. Okay, so imagine that there's no COVID, it's not online. My presentation probably would have started 5 minutes earlier because I wouldn't have been mucking around with this. We're all sitting on our chairs. So each one of those chairs in the room is a negative place where a cation, which is all of you who are sitting at home, can sit and be stored within the soil. So the room is our soil. The chairs are those negative exchange plates, and you are all cations: calcium, magnesium, potassium, sodium, and aluminium. Now we know that the amount of chairs within the room is determined by the amount of clay and the amount of soil organic carbon. So if we have practices which are reducing like our soil organic carbon, so we're getting a decline in soil organic carbon, we'd remove half the chairs from that room. Now we've got half of the attendees standing. So they're not held on to the soil, they're in the soil solution, they might be leached away and they might be removed. So they're not protected. So we've reduced the storage capacity of our soil now to hold on to and exchange those nutrients. The flip side though, let's say we brought more chairs into the room. So we can't readily influence the amount of clay within our soil, but we can certainly influence the amount of soil organic carbon. So by bringing more chairs into the room, we can have more people sitting down waiting for Susan to actually start a presentation. So by increasing soil organic carbon, we can increase our soil's capacity to hold on to and exchange nutrients. That, my friends, is very exciting. Now, there's no debate about this stuff as well. Like all soil scientists agree on the exciting role that soil organic carbon plays in soil function. We also know that soil organic matter is an important nutrient reservoir. Remember I said soil organic matter is 58% carbon, 42% other stuff, and that other stuff is important and has a value for our production. So we know that a 1% increase in soil organic carbon in the top 10 centimetres of loamy soil can be equivalent to about 1 tonne extra of nitrogen in that soil, about 200 kilos of phosphorus and about 170 kilos of sulphur. So there's real dollar values that you can assign to that. In fact, some really exciting research that came out of Victoria said in poorer soils, soil organic carbon was worth about $25 per tonne, $25 per hectare per year in increased productivity, mainly due to water holding capacity, which I'll talk about in a minute. In higher productivity perennial pastures, soil organic carbon was responsible for an increase in productivity of up to $95 per hectare per year through that productivity, largely through to that nitrogen mineralization, so that fertilizers, that organic fertilizer supply and cycling. So it's really exciting and they're real numbers. Okay, and then we've also got increased water holding capacity. So we know through a few different functions that organic matter has within the soil, primarily through supplying energy for activity of soil organisms, that we can increase the water holding capacity of our soil and increase the infiltration through increasing soil organic carbon. So a 1% increase in soil organic carbon is equivalent to about 20 to 30% extra water holding capacity in our sandy soils in the top 10 centimetres. So when we know that this is going to become increasingly important when we look at kind of changes in our climate as well. Now, the way that happens is as organisms, so our microbes within the soil, start breaking down organic matter, bacteria excrete substances which stick particles together. So we increase the stability of the soil. They also have electrostatic charges when they move through the soil. So we have clay plates which can stick together. We have mycorrhizal fungi, which kind of grows throughout the soil like a spider web through the soil, which kind of enmeshes aggregates and helps with that stability. So we've got glues, we've got mesh, and then we've also got that formation of aggregates and macropores through our bigger soil organisms as well, such as our earthworms and our dung beetles. So all of that enhances this structural ability of the soil to act like a sponge. And that aside, we also know that one of the most limiting factors often is going to be air. So our plants and our microbes need air, and that's another role that soil organic carbon can play through facilitating that enhancement in soil structure. And all of this comes down to functional carbon. So I'm saying it's got to be, it's food for our soil organisms to perform these roles, which often we're taking for granted, but are really, really important. So there's a range of ecosystem services that are also associated with increasing soil organic carbon and soil condition in particular. And the important part to think about this is that we've got these emerging markets, so these co-benefit markets of saying, yes, if you can increase soil organic carbon, that's one of the metrics, or soil condition because you're reducing soil acidity, and you've got practices which are reducing erosion, for example, we know that there is a public good benefit from doing that. And we know that there's these markets which are coming online, which are starting to value those. So we've got the National Farmers Fed with their 5% of, farm revenue coming from ecosystem service markets in the next kind of 10 years. We've got MLA, for example, kind of supporting so much work around carbon neutrality. So these are real and emerging markets. So there's a lot of opportunities in this space. So yes, going back to the scenario, most certainly there's benefits of increasing soil organic carbon. It is one of the only products that you can sell off farm that you retain the benefits of, right? So you can sell a carbon credit if that's what you decided to do, but you still get all those other benefits as I've just spoken about. So these essential functions of soil organic carbon can depend on the amount of clay and the type of clay within the soil as well. So we know for our cation exchange capacity, it's greater for our sandier soils than our clay soils. For soil structure, there's a bit of a sliding scale there, as for water holding capacity. But in terms of provision of nutrients and energy for our soil organisms, regardless of your soil type, increasing soil organic matter is really important for that. But it's important also to remember that soils will vary in their capacity to sequester and protect carbon. So it's about this balance. So we've got the soil organic carbon concentration dependent on organic matter supply, so that photosynthesis process and the net supply of carbon going into the soil, or organic carbon that's being brought to the soil if you're using organic amendments, and carbon loss. So that decomposition process, good functional carbon, but we can influence that as well, and reducing erosion. Now, we know that's going to be modified by the type of organic matter. So organic matter that's kind of high in nitrogen, so our leguminous organic matter that goes into the soil, is tastier than more of our carbon high organic matter, such as wheat stubble, for example. And that's going to influence the rate of decomposition. It's also going to be influenced by the soil's capacity to store organic carbon. So the amount of clay, the type of clay, the depth of soil, and the structure of soil. Now, these are the factors that drive productivity. Some can be changed, such as the plant type and soil structure, and some can't be changed, such as the amount of clay and the type of clay. But what we know is that we can build soil organic carbon at the same time of producing food and fibre, because we can influence the supply of organic matter through pastures, pasture composition, legumes in our pastures, stubble retention, cover crops, managing our nutrients so our plants can grow big and healthy, managing our nutrients for the microscopic livestock underneath so we can stabilize more carbon in that humic pool, looking at manures and compost being brought to the site, and minimizing the loss of organic matter, primarily through erosion, but also by making sure that the decomposition of organic matter that's happening is happening at the right time so that we're getting those benefits as well. So is it tricky to change levels? Going back to that scenario, we know that increasing biomass through good agronomy and grazing management and residue management can increase productivity, and it can also increase the supply of organic matter. Therefore, we can be building soil organic carbon at the same time through these good management practices. So what does the data actually tell us? In this table that I'm about to show you, there'll be a range of management actions. So this is all published literature. I've primarily focused on New South Wales because I'm totally biased, but I'll also have in there a couple of examples of meta-analysis for Australia, some great work that's done by Mark Farrell's colleagues. I've got the region, so where this work was done. The carbon sequestration rate is the next column. So that's the tonnes of carbon per hectare per year over which that carbon accumulation happens. That's to 30 centimetres. Remembering that it's not always linear. It usually happens more rapidly at the start than declines. The years over which the trial was conducted. So are we talking a 5-year trial or 18-year trial, for example, and the reference to that work. And you'll have access to this so that you can go back to, because it's a very busy slide. So when we think about pastures management, remember we're going back to my third slide. What can we do to grow bigger, healthier plants so we've got a greater amount of organic matter supply? So overcoming nutrient deficiencies, liming for acidic soils, grazing so that we've got actively growing plants for longer throughout the year, managing pasture composition, bringing in organic amendments, so bringing in carbon, not just thinking about the carbon that goes into the soil, but the priming that that can do for those microbial processes which facilitate greater carbon accumulation beyond just that net carbon change in the organic amendment. things like managing our irrigation schedules, introducing perennial pastures, and in some cases changing from a cultivated, degraded soil to a pasture. And that's sometimes where our greatest changes can be seen, restoring degraded land. Now, something important to think about here as well is the lower your starting carbon level, the greater the increase could be, the bigger the bucket is to fill. So if we look at these sequestration rates, this is all, there's nothing spooky about anything that's on this slide. It's in published literature, and we can see that through some of these practices, we can achieve sequestration rates in our environment from between 0.1 tonne to 2.5 tonnes per hectare per year. So that's pretty exciting. Some of the work that Jason mentioned before, the master trial, they maintained over 18 years, there was like a bit of bounce around with seasonal fluctuation, but about 0.5 tonne per hectare per year for 18 years, which is a great example just to show the role of good pasture management, pasture species selection, and managing liming to increase soil organic carbon. If we look at our crop examples, as I said, there's enormous potential from restoring degraded soils to pastures. And sometimes maybe carbon markets will be the incentive for that change. Minimum till crop to pasture, for example, has also got some figures of around that tonne per hectare per year. All depends on that starting carbon level as well. Pasture rotation, so you cannot undervalue or the importance of pasture rotations in cropping systems, because that's the opportunity to enhance soil structure, increase soil organic matter supply, put nitrogen, biologically fixed nitrogen into the soil, all of which is important for building soil organic carbon. So there's multiple strategies to build soil organic carbon. There's nothing spooky or weird about it. A lot of them are good management practices that we've got published data on. Grazing management in pastures, I think, is king. So thinking about timing and time so you can maximize organic matter supply, make sure you're maximizing ground cover as well. The other thing that's really important is that biological nitrogen fixation and making sure that we've got nutrients from microbes, but also for microbes, so those microbial processes. For crops, we've got a range of practices which we know are important for increasing soil organic matter and keeping carbon in the soil. But in general, we know that we need to be growing big, healthy plants, overcoming soil constraints, whether or not that's acidity or waterlogging, poor soil structure, or in some cases, changing that in practice on degraded soils, and also adding carbon-rich materials such as composts and manures. This is in green because there's an emerging body of literature here, some in Australia and a lot in the States, which I just think is super exciting around mixed species plantings, biostimulants, and microbes which are being, I guess, curated to store more stable forms of carbon. So the example of that is that melanized endophytic fungi. So there's some exciting stuff that's happening in this space, which means that this is a really an emerging industry, but it's also, I think, putting soil organic carbon back at the forefront of producers' minds. Its benefits beyond trading. It's about resilience and it's about improving soil condition. I guess I couldn't put up all of those numbers without saying, well, in some cases, why doesn't soil organic carbon increase despite best management? Because this is a question that I often get asked. Now, sometimes this can be because of large background levels, particularly under our perennial pastures, which mean that our increases in soil organic carbon just aren't detected over short timeframes. So, for example, if I had 2 buckets in front of me here, exactly the same size bucket, okay, and I fill one bucket up with sand, okay, so one's full of sand, you could look into those buckets and go, yeah, one's full of sand, the other's completely empty. Then if I get 1 cup of sand, if I poured that into the bucket that's already full of sand, 1 cup, you wouldn't be able to see it, would you? You'd be like, oh, I can't see any difference in what's just happened here. But if I poured exactly the same amount of sand into the empty bucket, nothing has changed in the amount of sand that I'm adding, you'd be able to see it in the empty bucket. So that's before, like where I was saying around this kind of the lower your starting soil organic carbon level, the bigger the increase can be and the more detectable that increase can be. That's not to say that you're not sequestering carbon under your perennial pastures. Perhaps we're just not detecting it over short time frames. But there's a whole lot of indicators around the benefits of what you're doing. Sometimes you'll have a ceiling of soil type and climate. So you have these environmental equilibriums that which drive production and organic matter turnover or decomposition, and that might be limiting that increase in soil organic carbon. Sometimes I've seen it's plant nutrition, so it also plant composition. Most certainly we get a bounce around in drought, and in some cases, if you've got a lot of particulate organic matter, you'll get a decline in soil organic carbon over drought, but then it kind of grinds to a halt because microbes will stop when it's dry and hot too. And then sometimes it's around that spatial variability. So perhaps particularly under our pastures, you've got this beautifully complex landscape and we're trying to collect measurements across that. So for carbon trading, there's some really good tools to account for that. But when you're monitoring your soils, depending on your strategy, you might not actually capture that variability, and that might be a cause of why you're not seeing increases in soil organic carbon. But sometimes it just might be that soil organic carbon is not sensitive to whatever management change you're looking at. But that doesn't mean that you're not seeing a benefit from your land management and that soil organic carbon isn't kind of being maintained at that higher level that you've already achieved. So this is my second last slide. And the focus of this slide is around kind of managing carbon flows. So the size of the arrows, not total stocks, because a lot of people just get caught up, I think, in the total amount of carbon that you've got there. If you're looking at your business and thinking, how can I just make sure that I'm photosynthesizing more, putting more carbon into the soil and letting less go out of the soil, then we know that that's going to be important for productivity, and it's a really effective and efficient way to build soil organic carbon. So think about your canvas. So think about the nutrient levels, the soil pH, all of those kind of abiotic factors in your farm management kind of canvas that you can influence. It's about grazing management as well. So thinking about how can you maximize that above ground input of organic matter as well as the below ground input of organic matter. When you have that, you'll get this engine room pumping. So I can not say enough just how important microbes are in this process. And I think for too long, we've kind of overlooked the important role that they play in supplying nutrients and enhancing structure and things like that. So this all flows into this engine room. So building soil organic carbon and enhancing microbial function goes hand in hand as well. Once we have that, we know that we can improve our inherent soil fertility. We can have a higher pasture quality, which then feeds back into this engine room of soil carbon as the energy source and microbial function, supplying nutrients and these other functions to our crops and pastures, as well as potentially a service that we could sell. And then we have this higher productive capacity. So in all of this, I'm not saying that it needs to be, it doesn't really matter where the nutrients come from. It could be tipped out of a bag or squeezed out of a chook, but it's about plants having the nutrients they require and microbes having the conditions that they need to function. So this was my scenario. I've tried to touch on it throughout my talk, but picking up on the key points, it is absolutely possible to build soil organic carbon as well as supporting productivity at the same time. So it's a dual purpose goal, and the two go hand in hand. Soil organic carbon percentage to measure in your commercial soil lab test that you get back from your agronomist is actually a really cheap and important indicator of soil condition. And I encourage you all to be monitoring this and creating your own benchmarks and even comparing with your neighbours or within groups like this. Carbon is cycling on your farm already. Even if you just walk out of your door right now, you'll see carbon is actually cycling already. If you want to change it and sequester more carbon, you need to think about what your biggest lever to pull is. Is it soil acidity? Is it a nutrient deficiency? Is it grazing management? And in most cases, it's probably going to be a combination of all of those things, but it's certainly possible to build soil organic carbon. The carbon markets, it's real, it's maturing. In order to think about whether or not it's for you, just think about your business goals and aspirations and see if it's a good fit. So can you increase soil organic carbon? Yes, you can. Can you trade soil organic carbon today? And we've got a new method coming out this year. Yes, you can. Will you make millions out of it? Maybe. Some people do. There's lots of examples of people that do. Should you be increasing soil organic carbon anyway? Absolutely. Sometimes there's going to be soil and climate factors that might limit your carbon sequestration rate, but there's enormous benefits beyond trading, which I hope I've kind of highlighted today. So in terms of increasing soil organic carbon, consider on your farm the right practice in the right place at the right time, and you'll maximize your opportunities to increase soil organic carbon.
We've got a speaker there, one of our producers, Jono Gardner. I'm hoping he's here from the Hamilton group, and he just wants to perhaps give us some insights into some of the stuff that they've been doing through their group and on their farm. Thank you, Jono. If you can just unmute yourself, Jono.
Yeah, no worries. Thanks very much. And thanks very much, Susan. That was great insights, and to a very evolving world of soil carbon and markets. But yeah, we had Cam Nicholson chat, and he chatted through quite a few things of those natures, and especially around the organic matter versus organic carbon, and how they marry up, and then talking through the particulate, humic, and recalcitrant carbons. And I think the big takeaways for me, and for probably speaking for our group, was just around the using that as a measure through your soil tests, like Susan was saying at the end there, and then just doing all the things that really aid you to grow more grass ultimately, which is utilising soil tests, using drainage where possible, then looking at, well, for our on-farm at South Macantia here, we're looking at building a perennial system. So we've actually taken paddocks out of cropping and put them into perennial pastures to aid that. And then keeping cover at all times, and that's utilising containment areas over that summer period. And then we're also doing a bit of a tree program at here as well, so increasing our tree plantings as well, but being strategic and more probably productivity driven, sort of aiding to that discussion that Susan was saying as well. Having productivity is a key driver of decisions. Yeah, they're the main things that that I took from our presentation, which was over 12 months ago now, but and then it being incremental changes as well, that you're not going to change everything tomorrow, so making long-term planning.
Fabulous. Thanks, Jono. So yeah, appreciate your input there. And yeah, good to see you doing so many different things on your farm. You know, it seems like you've had a go at everything, which is terrific. And our next producer speaker is Felicity Turner from the Kuriong Tatiara, I think it's Meningi group over in South Australia. So Felicity, do you just want to share some of your insights with us?
Yeah, thanks, Lisa. I'm actually presenting on behalf of Joe and Nige Williams today, who couldn't make it online. So I've quizzed them on what things they've found, because I actually help facilitate the group. So just a recap of what the Meningi East and Field Healthy Soils group's been doing over the past couple of years. We've sort of looked at different things, from soil modification and improvement through to variable rate applications, fertiliser applications in pastures. But probably a key thing with that is that with not much being spent on fertiliser for the past 20 years until prices started to improve, our soil nutrient levels are really, really low to start with. So sort of keeping in mind that variable rate's probably not applicable till we start to build that. We've also got quite a few dryland salinity issues. So we've focused on that, touched on soil acidity, and then had a fairly big focus on soil carbon, which is what we're talking about today. Susan, thank you so much. Your presentation was amazing. I often think with different things that there's a huge circle of concern, but within that circle of concern there's a small circle of influence. And I think you did a really good job today in actually just saying, you know, pointing that out, that there's only so much, you know, there's what we can control and there's what we can't, and really trying to focus in on those that we can. So thank you very much. It was great. Some of the key insights or learnings that we've had from particularly the carbon session that I got from Joe and Nige is that it's not simple or easy, and that it is a big complex issue that we're trying to address and deal with. I guess, sort of asked what can they easily do something about, and they sort of said probably the key thing there was testing. So, exactly like you've said today, just working out what their baseline levels are to start with, working out your baseline sampling. You can't measure can't monitor what you don't measure. So just trying to get that sampling done to start with, but also probably instead of just doing a normal 0 to 10 sampling, going deeper to that 10 to 30 centimetre zone to get a whole picture of what's happening. And the other thing that they could probably do is short term or, short to medium term is looking at maintaining or improving their soil cover. So, just being really conscious of their grazing management and trying to maintain green leaf area and soil cover all year, which again is reinforcing some of what you've mentioned today. Something that they could do something about but will take time is around some of those pasture mixes. So some of that novel ideas that you're talking about with regards to different pasture species and some more biodiversity in the mix, and are there some species that are going to help create more exudates than others? We're essentially a lucerne based system, so trying to put some herbs or something like that in there to try and increase the biodiversity, is that going to actually help build it? So that's probably something sort of medium term that they thought they could probably look at. And with regards to what they can't do much about and just have to manage around it, we farm on sandy soils. So the reality is it's only going to be able to hold so much carbon. And we're also sort of only a medium rainfall. So I know a lot of you have pretty high rainfall, whereas we're sort of that 450, 480 mil rainfall. But yeah, there's a potential there to look at amelioration to try and improve our bucket size and things like that, which we're working through at the moment. From their perspective, unanswered questions they still have about each topic, but lots, but probably the key one was some of those other management practices besides just, grazing management and different species and things to try and influence carbon. And some of us that are involved in the Healthy Soils group are actually tomorrow have a hookup where we're actually doing a carbon benchmarking workshop through Land Care Farming, where we're actually all benchmarking our businesses. So hopefully through that, we'll get some more information about other things that we can do on the farm to try and reduce our overall footprint, besides just looking at soil carbon from a soil health perspective. But the key driver, I think, for most of the people in the group is around building resilience in the soil. The carbon farming or the carbon trading is definitely an opportunity, but I don't think it's the primary motivation, and I don't think it should be. And that's it from me, Lisa.
I guess we might open up to the rest of the group in terms of questions for Susan, and then we'll wrap up. We'll just spend a few minutes answering some questions. Michelle, was there any particular questions there that kept reoccurring?
I'm not sure. Does Lisa Warren want to unmute and explain her thought that she put in the chat box?
Oh, okay. Thanks, Michelle and Lisa, and thanks, Susan, for a great presentation. Yeah, Susan, I suppose my concern is that people are getting carbon credits for changes in soil carbon that they've measured only after a few years, which I think is way too short a period to have any sensible measurement because of the variation and the error around measuring carbon. And they don't have control paddocks. So like in research, we'd have a control paddock where we could say, yep, it's definitely our management input has actually changed the carbon. It's not just a random thing because of seasons or whatever, or sampling or something. So that's sort of a concern of mine, that this is actually part of the scheme where people are getting money for it. There's no control paddock and they're measuring after a few years and claiming that they've had changes, increases in carbon and getting credits. I'm just wondering if they go back and test in a couple of years' time, that the carbon could go down again just because of seasonal variation, nothing to do with what they actually did.
Yeah, I hear you for sure. And that's where I think you need to weigh up the risk, because when you enter into like a carbon trading agreement, you kind of estimate, well, you have to first of all say what your practice change is going to be. And then you estimate what that increase is going to be. And then you have a crediting period, then you get your credits, but then you need to keep increasing. And if you don't keep increasing, then there's like, I guess, that risk that if it's not a solid practice change benefit that you've seen, and there's some bounce around over that auditing period, that you, I guess there's a risk that you might need to hand back. And the way you'd get around that, like you're saying, is kind of, well, doing your background research. For on-farm demo, if it's not carbon trading, control paddocks are kind of perfect. I always say, like, do a strip or leave a strip. And then I'm always dealing with absolute keen beans that I just go to the paddock and they've done it all. I'm like, what are we going to do now? But I love the motivation. But in terms of the carbon trading, it would also be making sure people, like, the way you could minimize that risk is starting from that lower baseline level, demonstrating that you're going to have an increase, but also just being real that those credits that you get, you might not want to on-sell them. So you might be issued with credits within the first 5 years of your crediting period. You don't need to on-sell those, because then if it does turn out that after 10 or 15 years, you're actually not increasing soil organic carbon, you've still got those credits sitting with you that you can either hand back or or you might even get a higher value for. But most definitely, I think there's a way that you can be a bit more risk averse and still participate in emerging carbon markets, because a lot of the practices which are on the positive list are all things that we perhaps would want to be doing anyway. Then the question becomes around, you just have to demonstrate that it's not business as usual for you. So that's where I guess some of the better land managers are like, I'm already like doing optimum fertilization and managing my soil acidity, I've got good grazing management already. Then unless you can prove that it's beyond business as usual, then that's kind of a no-go zone for you as well. So the benefit is, though, you're already getting those kind of benefits from carbon already, just not the trading part.
Yep, terrific. Michelle, any other questions there that we've got in the chat box that we think is worthwhile addressing?
Craig just made a comment that in terms of the carbon credits and things, there are a bioenergy plant set up locally in Ararat in Victoria where producers are selling their excess straw. So we're removing from our system because we have so much biomass with our crops. So we're removing that straw that's not going back into the systems, but should the value of our straw be higher? Because it could be our carbon.
And I think that's like a situation specific example. So if it's opportunistic this year to sell excess straw that you wouldn't be able to sow through anyway, and you're retaining some, then maybe that's the decision you'd make. Certainly, I remember going to a site in WA a few years ago, and they were harvesting straw, like stubble, for biochar, and like their row lines are like 80 centimeters apart, and there wasn't much happening in that paddock anyway. In that case, I was like, the value is in that standing stubble retention and protecting the soil surface. But if it's, as I said, if it's opportunistic now, then I can see where that benefit would could be. But for me, like, I'm totally biased, like it's all about the soil, so I'm like that organic matter retention. But if it just means you're going to have to burn it before you sow anyway because you can't get through it, then yeah, seems like it's a sensible option.
Because that's the hard thing with the high rainfall zone is we do create, the one good thing, we do create lots of biomass, but it's that trade-off with if you're going into a cropping system, how do you sow in? And I suppose that's something we're all still working through.
Yeah. And then there's like with some exciting stuff done around that. Well, you basically treat it like a bit of a recipe. You've got your stubble going in, you want it to break down quicker, you can add a whole heap of nutrients and then you'll get that formation of humus. But there's a cost to that, and that's like a very real cost in adding those nutrients just to build humus. So it depends. Yeah, anyway.
Yeah. Okay, so I think there's a few questions obviously in the chat box that we need to probably end up addressing, which I'm sure we'll have a good go at. But in the essence of time, I think we'll have to bring it to a close. And I think well, I've heard great presentations today, and our producers were terrific as well in sharing some of their ideas, and it's all about sharing information, and I think we've done that very successfully today.